Find the power series representation for the following function. Function is ln 5 minus x. Include the interval of convergence. Okay, so our function is ln 5 minus x. To find power series representation, we try to write a given function in the form of 1 over 1 minus something, and that produces something that raised to n from 0 through infinity, and the absolute value of that should be less than 1. Okay, we are just trying to find a geometric series with a common ratio less than 1. So we need to write anyway 1 over 1 minus something, so that we can write this. Okay, so for that, let's try. So we have ln of 5 minus x, but this is not in 1 over 1 minus something, not in a fraction, but we know that its derivative is 1 over 5 minus x times derivative of 5 minus x, which is negative 1. Okay, so we saw that derivative of this function is this. That means antiderivative of right hand side is this. Okay, that is antiderivative of negative 1 over 5 minus x is, with respect to x, is simply ln 5 minus x. So to find power series for ln 5 minus x, we can just find power series of this, negative can be pulled to the front, and integrate. Okay, so we just gather our thoughts. Let's start the actual. Let's do the actual work. Note that derivative of ln 5 minus x is 1 over 5 minus x times derivative of 5 minus x, negative 1. Then antiderivative of right hand side, negative can be pulled to the front, 1 over 5 minus x with respect to x is ln 5 minus x. Okay, so let's find power series for this 1 over 5 minus x. Okay, and we know that all we need is 1 over 1 minus something. Okay, so we can keep working on this left side, and then we will get eventually. Okay, so this one negative 1 over 1 minus something, but there is 5, so let's factor 5 out. 1 minus, there is no 5, means we need to divide by 5 because we factor 5 out. If you distribute 5 to inside, we get 5 minus x. That is equal to right hand side. Okay, we don't have to write that. So this one, now this 5 can be pulled to the front. Okay, so this one, we are just working on this. Negative 1 over 5, antiderivative of 1 over 1 minus, now we got something, which is x minus 5. And this is negative 1 over 5, antiderivative of, as we said earlier, 1 minus 1, 1 over 1 minus something is that something raised to n in power series, n from 0 through infinity. Okay, so since we can take the power series, antiderivative of power series, we can move this inside. So this is in fact equals negative 1 over 5 already outside, sum n from 0 through infinity, antiderivative of, let's write down xn on the top and 5n. So x over 5n means just xn on the top, 5n on the bottom. 5 raised to n can be pulled to the front. This one can be pulled outside of integral, not all the way. Minus 1 over 5, then sum n from 0 through infinity, 1 over 5n We cannot pull all the way outside because the sum is for n. Now we got antiderivative of xn, and that's just the power rule, xn plus 1 over n plus 1. N plus 1 over n plus 1, and when we integrate we get some constant c. Okay, we need to determine the value of c as well. Okay, now pretty much we are there. So the right hand side is ln 5 minus x. That's what we are, our function is. Okay, so that is ln 5 minus x is negative 1 over 5 sum n from 0 through infinity of 1 over 5 raised to n x n plus 1 over n plus 1 plus c. Before we find the value of c, we can just manage this 5 means 5 raised to 1. We can move inside, then we can combine 5 raised to 1 times 5 raised to n. We add the exponents, so 5 raised to n plus 1. So we can do that. Okay, so let's do that. So that is in the left side we got ln 5 minus x. That's the question, equals negative. Let's pull negative. We got negative there. Okay, we can just leave negative outside. We can put inside if we like, but that's all right. Just leave outside. N from 0 through infinity. This is 1 over 5 raised to n plus 1, and okay, x raised to n plus 1 over n plus 1 plus c. So many n plus 1s, and if you look at closely, n plus 1, n plus 1, n plus 1, and n it starts from 0. So the very first term will be, when n equals 0, so 5 raised to 1, x raised to 1, 0 plus 1, 1. So we can just write n there, subtracting 1 from each n containing n plus 1. So subtract 1, and we need to add 1. Okay, so subtract 1 in each, we have to do that. Subtract in each n plus 1, subtract 1 and add 1. That way we just have to write xn n 5 raised to n, and we can start from n equals 1. It's not needed, but this makes our series look better. So ln 5 minus x is in fact negative n from 1 through infinity, 1 over 5 raised to n now, xn over n plus c is there. Now to determine the value of c, so we are saying left hand side is equal to right hand side. We can just take x equals some value. The easiest would be 0. Take x equals 0. Left hand side is natural log of 5 equals negative. When we take 0, 0 raised to n, so this will be 0 plus c. So that gives us c equals natural log of 5, which is a decimal number. Okay, then thus final answer ln 5 minus x equals negative, or let's write plus c in the first place, c is ln 5. So I'm writing plus c first, which is ln 5 minus the series n from 1 through infinity, 1 over 5 raised to n times n and xn. Okay, but the question also asks us to find the interval of convergence, and when we write this at the very beginning, if you remember correctly, 1 over 1 minus something is something raised to n, and that something absolute value should be less than 1. So in our case, that something was x minus 5. Okay, so x minus 5, absolute value of x over 5, absolute value of x over 5 from here should be less than 1. Okay, so we can work here for the interval of convergence. we have x over 5, absolute value of x over 5 is less than 1. Multiply, this 5 is positive, so absolute value is 5 itself. So this is absolute x is less than 5. That means negative 5 to 5. Okay, center is 0. Radius of convergence is 5. So we go 5 to the right, 5 to the left. So that's the interval of convergence, final.